Hello, welcome to today's Tuva Science Connections, where we're going to think about influenza biodiversity and as it relates to HSLS2-2, where our students are working with mathematical representations to support and revise explanations based on evidence about factors affecting biodiversity and populations in ecosystems of different scales. So right, when we think about biodiversity, two common metrics that we use are species richness, how many species are there, and species evenness, sort of the proportion of those different numbers of species. So one way that can be really fun to have kids think about this at a different scale than what we typically use when we're talking about biodiversity is to have them explore the influenza strains. And albeit not different species necessarily, the different strains that we have and their prevalence across different flu seasons present some really interesting questions to think about. Things like which strain is the most prevalent in a given flu season, or how are different flu seasons similar? How are they different? Things like that. So we're going to explore some activities or some questions with the data that you can do in the prevalent flu strains in recent years activities. And we'll be using this data set. So let's dive in and take a look about what's going on in this data set, the influenza strains data set. So first off, where do the data come from? They're from the Centers for Disease Control and Prevention. And there are 826 cases and 4 attributes. And each case is a record of the from each week of the flu season. So not week of the year, but week of the flu season, how many specimens were collected, and then they're typed by different flu strains. These 4 attributes. So let's take a look at what those 4 attributes are. So we have the flu season, and just to get a sense of which flu seasons we have the 2008 to 09, 13 to 14, and 2017 to 18 within this data set. We have the week of the flu season, the different strains, and the specimen count. So we can quickly start kind of playing around and get a sense of like how many different specimens were counted in each flu season. Or we could ask questions like, bear with us, there are a lot of data points in this data set. We could look at sort of the different strains and how that's going across the flu seasons. And while this is interesting, we've got a lot going on down here in the bottom. So this is a great opportunity as we're trying to look at that first question of what's the most prevalent each season, changing up the graph type that we're using. So let's make this into a stretched bar chart. Let's get a sense of that we are seeing our percents by bar section. Perfect. So each flu strain is now showing up with, of all the specimens collected in each flu season, proportionally, what part of that whole of all the specimens collected were these different strains. And with the strains being different colors, and having the bar sections, the percents of those bar sections labeled, we can sort of quickly jump in and see, okay, no, like the most prevalent strain is not the same across all seasons, right? In 2008 and the 2008-09 and the 2013-2014 season, it looks like we had H1N1, the 2009 H1N1 strain was the most prevalent of these two, right? It's taking the most space, but not in the 2017-18. It's there, it was present, but it wasn't the most prevalent. Instead, what was most prevalent was strain AH3. So this is interesting, and we can sort of dive in and explore even more to think about what are the similarities and the differences across these. So we can look here kind of proportionally, what did we see? But we also, right, this is kind of proportionally of all of the specimens collected. How many were collected each season? So again, we can change our bar type to a bar by sums rather than a stretch chart. So now we're actually seeing the actual number of specimen collected by each strain. And so still we can see here in the 2017-18 that the most collected were this A3 strain A H3, right, which makes sense. That's why it was showing up as the largest percentage of that stretched bar chart. But what's interesting is that there were 20,704 of those specimens collected, which is less than half of the 45,000, more than 45,000 of H1N1 specimens that were collected in the 2008-2009 season. And so we can look at proportional differences, but then it's also helpful to look at the actual values of what was collected and what was tallied. And so by doing this, by coming through, like we're showing the sum for each bar section as well as the bar totals of what we're looking at, this gives us a better sense where we can dive in and we can start to see not only was the kind of strains that we saw, right? So here, this one, the strain B Yamagata lineage only shows up in the 2017-18 season of these 3 seasons. And so the number of species is differing, and the proportion, or the number of strains and the proportion of those strains across these flu seasons is differing. And this is interesting, right? If your students are familiar with our flu vaccine that we get each year and why we have to get the flu vaccine each year, this is how kind of looking at strains and data on the influenza strains can be interesting to get at biodiversity, this richness and evenness. And what did we see, right? The most prevalent strain varies by flu season. Similarities are that we see a lot of similar strains across all the 3 seasons we looked at, but not exactly the same, and that the number of specimens collected, which strain was most prevalent, the proportions of prevalence of each of those strains varied, right? So now we're starting to see with influenza strains that change, that have such a short lifespan, we can see how richness and evenness can vary over time. So this, of course, is just one of many life science connections that you can make using the Tuva datasets and Tuva activities. I encourage you to check out the content library, look for more that relate to your content area that's coming up in your curriculum. As always, reach out with any questions that you might have. You can search that content library by performance expectations or by topics, whichever you would prefer. We hope you have a wonderful day and enjoy playing with the data. Thanks so much.